Bismillahirrahmanirrahim. Today's lecture is about the domain and range of binary relations. But before going into the topic, first of all, we need to recall the definition of the binary relation. The definition was that a subset of the Cartesian product of two sets is called a binary relation. We know what a subset is, okay, part of a set. So it means that it is a subset, and the set to which this binary relation is a subset is the Cartesian product of two sets. So with the help of the example, I'm going to get two sets, then I'm going to find their Cartesian product. After finding the Cartesian product, I'm going to get a set which will represent all the ordered pairs of these two sets. And after finding the Cartesian product, I'm going to find the subsets of this set. Those subsets will be the binary relation. In order to understand this definition better, we will do an example. For example, let us take two sets. Let A be the set A and B, and suppose you have a set, second set, which contains the elements 1 and 3. Okay. First of all, let's find the Cartesian product of these sets. Now, what was the Cartesian product of these two sets? How we find it? By definition, Cartesian product is the set of all ordered pairs whose first element belong to set A and second element belong to set B. Okay, so the Cartesian product, as we have already studied, is denoted by A cross B. In order to find all the possible ordered pairs whose first element belong to A and second element belong to B, what am I going to do is I'm going to pick the elements of the set A one by one, and I'm going to write it with write ordered pair with the help of all the elements of the set B. I will make A the first element of the ordered pair, and the elements of the set B will be taken as the second element of those ordered pairs. So first of all, pick the first element of the set A, okay, make it the first element of the ordered pair, and now make ordered pairs with the help, pick A, okay, and then write it with 1, then again pick A, okay, and write it with 3. So in this way we have formed two ordered pairs whose first element belong to this set A, and the element that we have taken is the first element of the set A, small a. Okay, so you are going to take all the elements of set A one by one and then form ordered pairs by taking the elements of the set B as the second elements. So pick set A, pick the first element A. I have made ordered pairs with 1 and then with 3. Now, as we are done with A, now I'm going to take the element B and make its ordered pair with the first element of B. Then again I'm going to pick B and then make its ordered pair with the second element of the set B. Okay, and you continue this process until you are done with all the elements of set A and all the elements of set B. And this is the Cartesian product of A and B. So you are picking the first element of A and making the ordered pairs with each and every element of set B. Then you are taking the second element of set A and you are making the ordered pairs with all the elements of set B. Okay, so you continue this process until you are done with all the elements of the set A. Now the number of elements in A cross B can be checked by finding the product of the elements of the number of elements in A cross B is always equal to number of elements in A into number of elements in B. Okay, so number of elements in A are 2 and the number of elements in the set B are also 2. So the number of elements in A cross B should be 4. 1 2 3 4. It means that we have made all the ordered pairs of all the possible ordered pairs with the help of these two sets, and it means that this A cross B set is complete. Now once you get A cross B, the next step is to define the binary relation. Okay, binary relation is a subset of the Cartesian product. This is the Cartesian product. Okay, we have found the Cartesian product, and now we are going to make its subsets, and those subsets will be called the binary relations. Okay, so we have made the Cartesian product of two sets. We have taken two sets, made the Cartesian product of two sets. Now a subset of the Cartesian product of two sets. Now subsets of this set will be called the binary relations. So we know that the elements of this set A cross B are in the form of the ordered pairs. Okay, so this is the first element of the order this set A cross B. This ordered pair is the second element, this is the third element, and this is the fourth element. Okay, so the method of making the subset is same as we generally do while we make the subsets of any set. Okay, A cross B is also a set, but its members are ordered pairs. Okay, this is the first element, this is the second element, this is the third element, this whole thing. Okay, and this is the fourth element. These are ordered pair: first ordered pair, second ordered pair, third ordered pair, and fourth ordered pair. These are the elements of this set. I'm going to make the subsets of A cross B, and I'm going to use these as elements. Okay, so the first subset which belongs to every set is the null set, the phi. Okay, the empty set, which is a subset of every set, then obviously this set will also have a subset equal to phi. So this is the first subset that I have made. It means that I have made the first binary relation of these two sets. Okay, second is I am going to take all the singletons. Okay, as we have done earlier, in order to find the subset, what we do is we first of all we take the null set, then we take the singletons, single members, and make this singletons out of these members. Then we join two members at a time, and again make the subset. The same procedure will be followed here. So I have taken the null set. After that I am going to take the singletons. This is the first element, this is the first singleton, first subset of A cross B. This is also a binary relation. Then the third binary relation will be, you can make with the help of the second element. Okay, this is how we make the subsets. Okay, we take each member one by one, make the singletons. The fifth binary relation will be another subset, another singleton. Okay, so these are the singleton subsets which contain a single element of these ordered pair. So this is also a binary relation because it is a subset of this set. This is also a binary relation because it is the subset of this A cross B. Okay, a subset of Cartesian product of two sets is called a binary relation. All these are subsets of A cross B, so all these are called binary relation. You can form other binary relations also by making other subsets of this set. Okay, the next binary relation that we can form is we are going to make the subsets which contain two elements, two at a time. Okay, the first of all I am going to pick this element and make its subset with A3. This will be the sixth binary relation. Similarly, the next binary relation that we can take is take this member and make its subset with this elements. Okay, so this is the seventh binary relation. Similarly, A1 and B3. Now this is the eighth binary relation. Now as I have taken A1, I made it subset with A3, then again A1 B1, A1 B3. Now I have made all the possible subsets with the help of this element. Now I'm going to take this element A3 and I'm going to make its, I'm going to join this with this, pick these two and then make a subset which will be the ninth binary relation, and then similarly A3 can be taken with B3. Okay, now the 11th binary relation, I have taken A3, I have made it subset with B1, then A3 B3. Okay, A3 and A1 uh, uh, mm, I didn't write A3 with A1 because we have already done that. Okay, this binary relation will be the same as A3 and A1. So just pick the elements and then make it subset with the help of the elements which are coming after this. So now I will pick B1 and make its subset with B3. So from here, these are all the subsets which is containing two members of this set. As these are subset also, so these will also be called the binary relations. Okay, so if you have the set A cross B, then all its subsets, any subset of this set A cross B will be called the binary relation. This is a binary relation of this subset, this is binary relation, this is binary relation between A and B, this is binary relation between A and B because this is a subset of the Cartesian product of A and B. This is also a binary relation because this is also a subset of this set. So the only thing that you need to check is if you are given a set containing ordered pairs, you just have to check whether it belongs, whether it is a subset of A cross B or not. If it is a subset, then it means that it is a binary relation. Okay, so now let me make the subset which contain three elements. So I'm going to take A1 with A3, and then I'm going to take B1. Similarly, I'm going to take A1 with again A3 and use the fourth element B3. Okay, now I'm going to take A1 with, I have taken it with A3. Now I'm going to fix A1 with B1 and make its subset with B3. Now R15 will be, I have taken A1 with A3, okay, A1 with B1, okay, and A1 with B3 cannot be taken because we don't have any other element after it. So it means that we are done with the subsets containing this element A1. Now after A1, the turn is of A3. I'm going to fix this element B1 with it and take the third element B3. Now these are all possible subsets of the A cross B, which is containing three ordered pairs or three elements. First, 2, 1, 2, 3. Okay. Now R16 will be the whole set. A1, the improper one, A3, and B1 and B3. Now these are all possible subsets of A cross B, because we know that in order to find the possible subsets of a set, in order to find how many subsets of a set can be formed, the formula that we use is we write 2 and then raise it to the power which is equal to the number of elements in A cross B, 1, 2, 3, 4. So if we raise 2 to the power 4, we get 16. So it means that this set has 16 subsets, and which implies that this set has 16 binary relations. Okay, because binary relations are subset of this set, and this is how we find the number of subsets of a set. If we are given 4 elements, then the possible subsets are 2 raised to the power 4. Okay, so these are all binary relations of A and B from A to B, because these are the subsets of the Cartesian product from A to B. So this is the definition of the binary relation. A subset of Cartesian product of two sets is called a binary relation. So we have taken two sets, we have made its Cartesian product, then we made all the possible subsets. All these are binary relation of from A to B. So in the exercise they are going to ask 2 or 3 binary relations. Okay, in that case just choose any 2 or 3 out of these, and then you can write them as an answer. I have made all the subsets to make you understand the meaning of the binary relation. Okay, you don't need to find all the subset in all the questions. Now we know what is binary relation. These are all binary relations. The next step is to find the domain and range of binary relation. For that, I'm going to use same example maybe. Now moving to the definition of domain and range of a binary relation. It is so easy. The domain of the binary relation is domain of binary relation. It is the set. Okay, so take care that it is a set. You are going to write it its elements within the curly brackets. The set containing the first elements of the ordered pairs in a binary relation is called the this is the definition of the domain, and let me write the definition of the range also. Range of the range domain is the set containing the first elements of the ordered pairs in a binary relation, and the range is the set containing second elements of the is called the range of binary relation. Okay, I will explain it with the help of the example. First of all, what we are saying is domain of the binary relation is the set containing the first elements of the ordered pairs in a binary relation. Now we had calculated binary relations a few minutes ago. In that you had seen that in the binary relation we have ordered pairs, and in each ordered pair we have two elements, the first element and the second element. Now if you collect all the first elements from all the ordered pairs in a binary relation and make a set of it, then that set is called the domain of binary relation. Similarly, if you pick all the elements, the second elements of the ordered pairs in a binary relation and make a set of it, then that set will be called the range of the binary relation. In order to understand it better, we'll do an example. For example, if you are given a binary relation, let us suppose you are given a binary relation A1 B2 and B4, suppose. Okay, suppose you are given this binary relation. Now if I want to find the domain of this binary relation, what am I going to do is I'm going to write domain of R equals to Now I'm going to pick the first element of this is an ordered pair. This is the first element, this is the second one. This is the second ordered pair, and this is the first element, it's the second element. Similarly, this is the third ordered pair whose first element is B and second element is 4. So if I pick all the first elements A, B, and over here again I have B, I'm not going to write it again. Okay, I'm going to write it just once. All the elements that we have used in this binary relation as the first elements are A and B. So this will be the domain of this binary relation. In order to find the range, in order to find the range, we are going to pick the second element. Okay, the second element, the numbers which are used as the second element of these ordered pairs are 1, 2, and 4. So I'm going to write 1, 2, 4. So domain of R, this is the set containing the first element of these ordered pairs, and this set is containing the second element of the ordered pairs. So this is called the domain of the binary relation, and this is called the range of the binary relation. Once again, let us see the definition again and we will understand it better now. The set containing the first element. This is the set containing the first element of the ordered pairs. These are the ordered pairs. Okay, first ordered pair, second ordered pair, third ordered pair. So the first element of these ordered pairs, we have formed a set of these first elements is called the domain of the binary relation. So this is a binary relation. These are the ordered pairs. This is the first element. This is the second element. If you pick the first element, make a set. This will give you domain. If you pick the second elements of the ordered pairs and make a set, it will give you the range of the binary relations. And this completes the definition of the domain and range of binary relation. In the next lecture, we are going to do the exercise relating to these topics.